Okay, so exercise 10b, graphs of the polynomial functions. Now we have covered this before in the previous chapters. I can't remember which one is chapter 4 or chapter 5 when we started to like sketching the curves. All right, we've done this before, so this is just a little short revision lesson about how to sketch the polynomial functions. So we're going to start with an example straight away, and then I'm going to show you the step-by-step working out, and hopefully you still remember how to do the questions before. So imagine if we have like in a polynomial function, obviously the first step is like, an to the power of x, and let me just write this as a general polynomial first. Okay, a1x plus a0. Okay, so if we have a polynomial function like this, all right, obviously the first step, if you want to sketch this without using calculus or differentiation, later you're going to use the calculus differentiation anyway, but at this stage, if we don't use the calculus differentiation method here, the first step is you need to factorize. Okay, so factorization is the major steps of solving this. So you need to change that, polynomials into those different factors, like, something times by something else. Depends on the degree of the polynomials, right? Then you can have, so if it's degree of 2, then you can have 2 factors. If it's degree of 3, you can have, a maximum of 3 factors. You can have 2 as well, but you can have like double root, double factors. But anyway, that's what you do. And then you sketch. Okay, so for this exercise, we are only going to just looking at these steps here. So all the questions in this exercise, they have already factorized for you. You don't need to factorize it unless it's something that's really simple. You just take an x out to factorize. Otherwise, it's already factorized for you. There are a couple of questions that's not factorized, but they're just quadratics. Okay, so which is pretty straightforward. All right, it's not hard at all. Okay, so I'm going to use a couple of examples to show you the steps, and I really hope that you still remember. And I'm just going to do probably 4 examples. All right, and these 4 examples will cover everything that you need to know for the polynomials curve sketching. All right, so the first example is something that's really basic and very simple. All right, so the beginning examples. So we've got x times by 3x plus 2 times by x minus 3 times by x plus 2. Okay, now really hope everyone remember this. And the first step, all right, is you always find the zeros. All right, just calculate, let this one equal to 0 and calculate what is the solution, all right, for each of the factors. So you find the number, the zeros. All right, so if you find the zeros, you're going to get like, let fx equals to 0. Therefore, x equal to 0, x equal to minus 3 on 2, oops, minus 2 on 3, x equal to 3, x equal to minus 2. So you find the zeros, that's the first step. Right, when the first step is finished, right, so that's the first step, okay, find zeros. So when the first step is finished, then the next step here is you're going to start step 2, all right, you just need to plot the zeros, or plot the zeros. Okay, very simple. Plot the zeros, which means you start now drawing the horizontal vertical axis. All right, so it's not hard. So just drawing the horizontal vertical axis, plot the zeros on the horizontal axis. So the first one is equal to 0. That's the first point using different color. Okay, do your labels 1 and 2 and 3. -1, -2, -3. So the next one is minus 2 on 3, which is roughly here. Minus 2 on 3. And then 3 is here, and the minus 2. So you've got 3 zeros. You can draw some big dots to indicate, the function eventually is going to come across those points. All right, so this is the step 2 finished. All right, once you finish the step 2, you now then start to find the Y-intercept. All right, so the next steps will be just finding the Y-intercept. Step 3, find the Y-intercept. Obviously, some people prefer to find a Y-intercept as a step 4 to 5. That's fine. There is no difference, okay? Now, with this question, the Y-intercept is just this point, okay? Because when you substitute 0, 0, 0, 0 inside, it's just equal to 0. So find Y-intercept, in this case, same points, okay? So there is no difference right now. Okay, so I'm just going to put it here. Once we have done that, all right, the Y-intercept we have identified. Then the next critical information that you need to do is check the sign of the leading coefficient. I remember I told you this. I hope you still remember this method. I don't use the textbook method. Obviously the textbook method is the method I'm using right now. But it's how can I say that? It's very hard to understand. It's not practical for students to understand it this way. I just have my own way of system or drawing this function here. So yeah, check the sign of the leading coefficient, and it always works. All right. So the sign of leading coefficient. This is how you check it. You look for the coefficient, for the coefficient, basically for the sign of the coefficient. That's positive, positive here, positive there. So when they're all positive, eventually you can remember if you expand, this is going to be a degree of 4, all right, polynomials when you expand it. So if all of those are positive, when they expand, you're going to get a positive coefficient or positive leading coefficient. All right, so if it's a positive leading coefficient, okay, so I'm going to write here, positive leading coefficient. Then the graph starts from the top right. If it's a negative leading coefficient, the graph starts from the bottom right. Now, I remember some students in the class were saying, hey, can we just summarize this one as the top left or top bottom left? Yes, you can, but I prefer just do it from the right. I don't know why. This is my habit. So now I know the graph is going to start from top right, somewhere here. You don't need to know where, okay? It could be here, there, doesn't matter. We just want an overall graph, all right? It doesn't really matter how low the graph is going to be, how high the graph is going to be. Eventually, we are going to find out using the calculus. So this is what we're going to do now. The graph is going to be like, start from the top right, passing through the point 3. So first passing through this point, and it goes downwards, okay, until it turns back and again and pass through the point 0, and coming back and again, okay, pass through the points of -2 and 3, and eventually pass through the -2. Okay, now this graph is not going to be accurate, I can tell you, because I don't know how low those points are, how high this point is. You can check, okay, you can substitute roughly this value here to check, but there is no need for the question in this exercise. You just need to know the overall shape of the graph, and obviously you can use your decimals to check, all right, as long as the overall shape of the graph is correct, then it's correct. Remember, it must be a single smooth curve. Okay, this is not art. Don't do something like this. I've noticed some students sometimes they do something like that. It's a single smooth curve. All right. Also, the next thing you need to, it's very important is every single time when you sketch it, you need to pay attention to the powers of the of each factors. If it's power of 1, perfect, it just passes through. If it's power 2 or 3 or 4, then we're going to have a different way to sketch it, which is going to be in the later exercise, examples that I would like to show you. Okay, all right. So this is example 1. 3 more examples. All right, example 2. And this is an example I'd like to show you where you have a powers. Okay, so sketch y equals to 2x plus 1 to the power of 2, x minus 4. All right, so I'm just going to do this question. This time I'm not going to write down step by step. So I'm just going to do it. All right, so the first step is you let y equal to 0, x is equal to, so if you want to show working out, that would be 2x plus 1 to the power of 2, x minus 4 is equal to 0. So x is equal to minus half, x is equal to 4. Okay, excuse me. All right, so once you have these two results, I do want to find the y-intercept as well. When x equal to 0, y is equal to 1 squared times by minus 4. Okay, which is minus 4. Perfect. All right, next leading coefficient is positive here, so the graph starts from the top right. All right, so I'm going to start to draw the graph. Okay, so 1, 2, 3, 4. First, there's a point here. There's a point that's negative half. Okay, so that's -1. So negative half is roughly here. That's negative half. All right, next we also have a a y-intercept. 1, 2, 3, 4. That's -4. Now, of course, you need to use your ruler to actually make sure that the scale is right. Okay, so once this is done, then you start to draw the function by checking the leading coefficient. I know it's positive, so the function starts from the top right, passing through the 4. Okay, passing through the 4. Okay, and it must pass through this point here as well. So I feel like the graph is going to be like somewhere going here, pass through this point, passing through here again. Now, the graph needs to turn back to go through this point here. But then if you look at this point comes from this factor with a degree of 2. So if it's a degree of 2, it's like a quadratic. So instead of the function that passes through this point, now this time the function is going to turn around. So you will have a turning point at this point here. Okay, so this is what happens when you have a graph that is, so it has a power of like 2 or 3 or 4. If it's 3, it's a different case as well. Let me just draw a slightly better diagram here. I don't really like my previous one. As I said, I don't know how low the point is. I don't even know if that point is the turning point or not. Later, we are going to find out using calculus. Okay, so this is a terrible drawing. Emphasize has to be a single smooth curve. All right, here we go. Probably it's not a good diagram again, but this is good enough for you to get the marks in exams. All right, because you actually demonstrate all the information. All right, the turning point here, the x-intercept, the y-intercept, the general shape of the curve is correct. All right, so that's example 2. All right, now what I'd like to show you is a question where the leading coefficient is negative, and we also have a power of 2. Sorry, a power of 3. Okay, and how do we sketch it? Let's sketch. So let's have a look. We're gonna sketch this question here. Y equals to x plus 2 square 3 minus x to the power 3. All right. So let y equal to 0. You can solve this question by just follow the same method. Let y equal to 0. X plus 2, 3 minus x to the power 3 is equal to 0. X equal to minus 2, x equal to 3. Next, you let x equal to 0. So that y is equal to 2 to the power of 2. Now be careful, you still have a power of 2 there. Times by 3 to the power 3. Oh, it's going to be a large number here. So it's 4 times by, what's that, 27. 108. Okay, well, I can do that calculation pretty fast. 108 without using a calculator. Amazing. Okay, what's next? Yes. I'm going to start to draw the graph. That's the whole purpose, right? Drawing the graph. All right, so -2, okay, and 3 is here. Now, 108, obviously, it's going to be a scale diagram. You can't draw the 108, so I'm just going to put 108 here. It's going to be a straw, a scale diagram. All right, next, the important thing here this time is what's going on with the point around here. Now, leading coefficient is negative. I'm just checking that for you. Okay, so have a look. Negative, positive. When they multiply together, it's negative. That negative to the power 3 is still negative, so that's still negative. If that number is 2, then it's going to be a positive. So leading coefficient is negative means the graph starts from here, somewhere here. But then at this point, the power is equal to 3. So what does that mean is if the power is equal to 3, what we need to do is we need to draw the graph like a cubic style, okay? And that's power of 2 here. And we know the graph starts from the bottom right, okay? So this is what we are going to do. And this is what I'm going to do, okay? So it's going to be like this, okay? It's going to go through that point. All right, and coming back again, and then going up. All right. Now the question here is, how do I know, where is the highest point? Do you think the highest point is going to be here and going down, or do you think the highest point is going to be somewhere here and going down? Again, you don't know, okay, unless you use your calculus, unless you actually do the checking. For the purpose of this exercise here, we don't care, okay? We just want some features. I'm just going to highlight the features for you, okay? This is what I'm looking when it comes to the exams. I'm looking at this point. I'm looking for the features here around here. I'm looking at that point here. I'm looking at the entire graph, whether the graph is actually starting from the correct direction. I'm looking for those information, okay? All right, this is example 3. Now, example 4, what I'm going to do is use example 3 to do the example 4. Example 4 will be something like, use the graph to solve inequality. So it's like, you solve this inequality question. So same question here. I've got a graph in front of me, but it's greater than or equal to 0. Okay, for example, or less than 0, or less than or equal to 0. Doesn't matter which one. But you're using the graph to solve it. Okay, so we call that a graphical method. Now you should be able to solve a very hard, inequality question like this. So how do we solve it? Well, we just need to identify the part that is above the x-axis. And as actually you can see here, this part here is above the x-axis. So therefore, once you know that, the answer to that question is pretty obvious. It's greater than or equal to 0. So therefore, x is less than or equal to 3. Anything that's less than or equal to 3 becomes the answer. Just have to be very careful about if this question is changed to, just greater than, not equal to, but just greater than 0. In that case, you can't include -2 and 3. So what you can do is you can write two different ways of writing it. You can write on x less than or equal to 3, except x equal to 3 and -2. Or you can also write something like, or you can write x less than or equal to -2. Oh, there's no equal. -2. There's no equal. Oh, that's equals on there. Yep, sorry. Okay. And then x is less than -2, or x is in between -2 and 3. That's also something that you can write. All right. So this is what we are going to do when we're dealing with inequality solving here. So, if you want to solve an inequality question involving polynomials, this is what you need to do. You need to sketch the graph, identify which part of the graph is above or below the x-axis, and you solve it. Okay, and be careful about the actual inclusive point, or if the point is not included. Okay, that's kind of like a revision lesson. We've done this before, and hopefully that gives you a little review about how to sketch the polynomial functions. All right, thank you.